In this video, we're going to be talking about congruent segments of a line or line segment. These first couple examples have to deal with the midpoint of a segment. Definition of a midpoint is that the midpoint bisects the segment into two congruent segments. So looking at example 1, in the figure below, B is the midpoint of segment AC. And using this information, it asks us to find X and then the length of AC. So if B is the midpoint, we can mark this segment AC to show that B is the midpoint with a little tick mark showing congruence. So this shows us that AB is congruent to BC, which makes B the midpoint. So if segment AB is congruent, and notice how I'm marking congruent, to segment BC, then I can set the two values equal. So 2x plus 12 equals 5x plus 10. In order to solve, I can algebraically solve this by combining like terms. I'm going to subtract 2x on both sides, and then I'm going to subtract 10 on both sides. And then in order to solve here, I'm going to divide 3 to get x by itself. And here I get x is equal to 2/3. This second example, back up to the first, it says find x. You want to make sure that we're answering all parts, like I almost forgot. It says to find x and then also to find the segment AC. So in order to find the segment AC, I need to plug 2/3 in for x. So when I do this, I'm going to do it using a calculator. I'm going to say 2 times 2/3 plus 12 plus 5 times 2/3 plus 10, because if I want to find the total length of this segment, I'm going to add these two pieces together with the value of x. And I get roughly 26.67 for the length of the total segment. So now in example 2, it says in the figure below, C is the midpoint of AB, find X and AC. So I can mark my congruent segments based off the information that I know that C is the midpoint. And in order to solve for X, I can set both segments equal to one another. I'm going to subtract 5x on both sides, divide by -3, and I get x is equal to 2. However, I also need to find the distance of segment AC. Now notice this is not the total distance, this is the segment AC. So in order to do this, I'm going to plug 2 in for x. 5 times 2 is 10, and 10 minus 6 gives me 4. In example 3, it shows us that it tells us that y is the midpoint of segment XZ, but then it gives us the distance, the total distance of the segment. So we can still mark that XY is congruent to YZ, but in order to solve this example, we know that if the entire segment is a value 20, that half of that segment would be 10, because 20 divided by 2 would be 10. And so I can set half of this segment equal to 10, and then set it equal to the expression they give us to solve for x. So then I would solve by adding 6 on both sides, and then dividing by 4, which would leave me with x equals to 4. Now for our final example, in the figure below, G is the midpoint of EF, find X, and EG. So G is the midpoint. I can mark the congruent segments. In order to find, in this case it's asking for X, but what I think it means is Y, so a typo on the county's part. I want to set the congruent segments equal to each other, and then solve by combining like terms. Which add y on both sides and then divide by 4 would give me y is equal to 9. But then in order to find EG, I would plug the value 9 in for y in this segment, and which is 3 times 9, which I would get EG is equal to 27.